All right, in the last lecture, we stopped here where we basically looked at the rotation of the moon around its axis and the revolution of the moon around the Earth. And I told you that the moon rotates around its axis at the same rate as it revolves around the Earth. And that's why we always see the same side of the moon. There is, I think, a point of confusion as well. I will deal with it. And when we talked about when you look at the faces of the moon, and I told you they're always moving toward the east. That's every night. However, if you look at the full moon, I told you that the full moon rises from the east, and it will be at the highest point around midnight, and it will set in the west around just before sunrise. That's because of the rotation of the Earth, okay? So you may actually say that I see the moon moving toward the west. It's like seeing the sun moving toward the west every day. But during the year, the sun basically moves eastward. And the moon also, during the month, it's moving eastward. But during the night, it may actually start like the full moon. You can see it in the east and then goes into the west. So I don't want you to confuse these two issues. Now, in the last lecture, I told you that in the next lecture, we're going to deal with lunar and solar eclipses. So what is a lunar eclipse? Well, a lunar eclipse happens when basically the moon is not visible as usual to you. So that will happen when the sun, the Earth, and the moon line up, meaning that the moon is in the shadow of the Earth. So if that happens, then you will have a condition for a lunar eclipse. But this alignment here, when you have the sun, Earth, and the moon in one line, only happens when the moon is full. So again, a lunar eclipse only happens when the moon is full. But you can also argue that we have full moon every month. And why don't we have a lunar eclipse every month? We'll try to deal with this later as well and try to explain that. But lunar eclipses happen when the full moon falls in the shadow of the Earth, as you see in this cartoon here. So let's talk about a condition in general. You have some spherical object here, and this spherical object comes in the path of a light source that can send lights in all directions. Now, of course, you know, when an object is in the path of light, it will form a shadow behind it. It will basically block the light rays behind it. So if you look at an object which is like the red ball here, which is a sphere, okay, and you look at the shadow behind it. Now, what will happen, okay, you will have a shadow that what we call a dark shadow here behind the red ball, and we call this umbra, okay? And this is basically the dark shadow that forms behind the spherical object. It's like a cone, and you know what a cone is. You're all familiar with ice cream, you can always have a cone of ice cream, and then you can have a scoop, and the top of it, that's basically the situation here. So it forms like a cone. So the shadow does not extend all the way. It will fall and it will end at some point. And if you go behind the shadow is going to, the size of it, it will be like a disc. At some point, that's exactly what you have here. Now, there are some rays like what you have, and they will extend, and they give you this inverted cone, and this is what we call penumbra. That's what we call shibh al-dhill. And the emperor here is the dhill. So if anything falls in the emperor, which is the shadow, of course is going to be blocked. So when we talk about the Earth, when it's basically facing the sun, it will have an emperor behind it, which will basically extend all the way up to here. And it's also going to have the penumbra. So now we look at where the moon orbits the Earth. So as you see here, this is the orbit of the moon around the Earth. And that is the size of the emperor, and this is the size of the penumbra. Now, if the moon gets into the emperor, then in this case, we're going to have a lunar eclipse. If it's somewhere in the penumbra, then we say penumbral eclipse. So, but if it's the entire surface of the moon is in the emperor, in that case, we have a total lunar eclipse. So the condition for a lunar eclipse only happens when the moon is full and when the moon is in the shadow of the Earth. That's the situation when we have a lunar eclipse. If the moon is entirely inside the emperor, then in that case we have a total lunar eclipse. So, for example, you can see in this figure here, the dark side that you have here, that's basically the size of the emperor at the location where the moon is orbiting the Earth. And if the full moon enters this region, then we're going to get a total lunar eclipse. So you can see when the moon or the full moon is outside this region here, you can see it bright. Then part of it is not seen, and the other part is still bright. When it's totally inside the emperor, that's when you're going to see a total lunar eclipse. Now, so if you see this effect, that's sometimes some people look at it, it's as if there is something eating the moon. And some, in old times, people, they used to get anxious when they see something like this, and they get scared, thinking that there is something in the sky that basically going to consume the moon. But this is something that happens naturally. Now, I want you to look at the moon here, and the moon here is, you still see it, but you see it as reddish. Sometimes we call this blood moon, or بالعربي نقول القمر الدامي. It is faint, not totally blocked, but you see this reddish, and sometimes we call coppery red. You know what the color of copper is. Copper basically has a reddish color. So we say this coppery red as well. And we'll explain shortly why we see this effect. Now, what we have here is a total lunar eclipse that lasted for 1 hour and 40 minutes. So it stayed for a long time. And it's giving you this reddish glow, and this basically comes from the atmosphere of the Earth. In chapter number 5, maybe I will make this more clear, but you all know about refraction of light. If you take a pencil and you put it in a glass of water, it looks broken to you. If you pull the pencil out, it's not broken. So why it's broken? It's because of what? Because of refraction of light. Now, you also know of the colors of the rainbow. They start all the way from violet all the way to red, and you see the 7 different colors. Now, the Earth, it has an atmosphere around it, and sunlight that enters this atmosphere. The light that hits the surface of the Earth is blocked, but the light that enters the atmosphere of the Earth will refract. And it will refract at a certain angles. Now, since light is composed of 7 different colors, and red light has the longest wavelength, at the location where the moon is, only one component of light, which is red, is refracted and can hit the surface of the moon. And that's why we see this reddish color of the moon. It is faint, but it has this faint reddish color or coppery color, or sometimes we call it a blood moon. It all has to do with the refraction of sunlight through the atmosphere of the Earth, and the longer wavelength component of visible light, which is red, can reach the surface of the moon, and it gives you this faint reddish color. So that's why we see this. If the Earth does not have an atmosphere, then you're not going to see the moon. It's going to be totally blocked. But the reason we see this, it's because of the refraction of sunlight that enters the atmosphere of the Earth. Is this point clear? So that's when we look at a lunar eclipse. Now, on May 26th of 2021, I told you that there is a lunar eclipse, and we also talked about a supermoon. But at our location here in Al Ain, it was not visible for us. You have to see that from North America and New Zealand and so on. Now, if you look at when we talked about what time is the full moon rises and what time it is setting, and at what time it happens to be at the highest point in the sky. Now, the time when the full moon was in its total lunar eclipse, or it was eclipsing, at our times here, it was noon time. So we do not see a full moon. And that's why we did not see the eclipse. but those who are in places where they have a full moon in the sky around that time, and there is a condition where the moon is in the umbra of the earth, they actually witness a solar eclipse. So now, how do we look at the types of lunar eclipse? Now, if the moon is in the umbra, in this case, what we have is we have a total lunar eclipse. بالعربي نحن lunar eclipse نسموه فيه الخسوف. Now, if it is coming in such a way that not the whole moon or the surface of the moon is in the umbra, part of it is in the umbra, the other part is outside. In this case, we have what we call partial lunar eclipse. But if it basically goes through the penumbra, we call that the penumbral eclipse. So we are dealing with either a total lunar eclipse or partial lunar eclipse. Now, in this, it's taken from the textbook, where you can basically look between 2012 and 2019. And in this table, it tells you the length of the eclipse, how long it's going to stay. And this is basically, it tells you the time for totality. So, for example, in June of 2012, there is a lunar eclipse, but it was partial. But in April 15, 2014, there is a total lunar eclipse, which lasted for 1 hour and 18 minutes in its total, which actually in the shadow of the earth, but going in and coming out, that means partial, then total, then partial. That basically took about 3 hours and 35 minutes. And there are now softwares that can basically tell you at what time we're going to have a lunar eclipse, and the location, and who can witness the lunar eclipse, and so on. But in general, we have about 1 to 2 lunar eclipses every year, and they last for 1 hour, 2 hours. Okay, it's a good time. And anyone that at this time having a night time during the time of rise and setting of the full moon, then they may have a chance to witness a lunar eclipse. So many people go and they witness lunar eclipses during their life times. Now we have an argument here. What would a total lunar eclipse look like if the Earth had no atmosphere? I told you, you're not going to see the moon. What we see it as a blood moon, or coppery red, or faint reddish color, it's because of the atmosphere of the Earth. So if you have sunlight that refracts from the atmosphere of the Earth. So if it's basically no atmosphere at all, then the moon is not going to be visible to you. What would a lunar eclipse look like if the moon and the Earth were the same diameter? Well, if we actually want to discuss this, if the Earth and the moon are the same diameter, well, the size of the shadow of the moon, where the moon is orbiting the Earth, is not going to cover the whole moon, because this could be about the size of the shadow, and that could be the size of the moon. So you'll see a donut-shaped moon in the sky. Only half of it is blocked. Of course, this is hypothetical. The moon is not the same, the diameter of the moon is not the same size as the Earth. So the size of the shadow of the Earth where the moon passes is less, and that's why it can be basically enters in the Impra, and that's why we see a total lunar eclipse. Is lunar eclipse clear? So a lunar eclipse happens when we have alignment of the sun, earth, and moon, and that only happens when we have full moon. So that's the situation. And you have to have the moon appearing in your sky during that time. So as I told you, on May 26th, we had a lunar eclipse, but in Al Ain here, it was daytime for us. So the moon was not up in our sky during the day, and that's why we did not see it. But those in North America and New Zealand and so on, they were able to witness this lunar eclipse. The second condition that also due to the moon in the sky is a solar eclipse. And a solar eclipse will happen when the sun, the moon, and the earth lined up. And from the name, solar, that means the sun now is blocked and you cannot see it here on the earth. However, the moon is smaller, so the shadow of the moon, where it strikes the earth, it cannot cover the whole earth. It only covers a small portion of the earth. So when there is an alignment of sun, moon, and earth, and that only happens when it's a new moon. If that happens and they're aligned well, then those who are at the region where the shadow of the earth strikes the earth, then the people there will see what? Will see a solar eclipse. That's different than the lunar eclipse. So we may have conditions for a solar eclipse, but not everyone will see the solar eclipse. Only those where the shadow of the moon is hitting the surface of the earth. At that location, the sun will be blocked and they have a solar eclipse. So generally speaking, lunar eclipse happens when we have full moon, and solar eclipses happen when we have a new moon. So when we look at object in the sky, we can measure, of course we cannot measure diameter, but what we can measure is basically we measure their diameter, or what we call angular diameter. We measure the angle that it subtends to our side here. So for example, the moon makes an angle of about ½ a degree, which is about 30 minutes. That's the angular diameter of the moon. And it happens that the sun also, from our location here, it makes an angular diameter of about ½ a degree or 30 minutes. Of course, the sun is way, way bigger than the earth and the moon. But the moon is 384,000 kilometers away from the earth. but the sun is 150 million kilometers away. So when we look at the angular diameter, that's why both of these are the same. And when they are lined up, then in that case, okay, the shadow of the moon can basically cover the sun, and we have a condition for a solar eclipse. So you look at the sun here in this cartoon, you look at the moon, and the moon again has the umbra and the penumbra, and you can look, that's only the part of the dark shadow of the earth that can hit the surface of the earth, and only those who are around this area here, or this path on the earth during the alignment of the sun, moon, and earth, which is a new moon, they can basically witness a solar eclipse. So as you can see here, you can see this portion here, which is basically a path around the surface of the earth. And this is basically when you can witness a solar eclipse. As you can see here, there are some photos taken here to show you the dark shadow of the moon here, where it can block the sun, and you have a condition for solar eclipse. So a solar eclipse can only happen when we have a new moon. We need this alignment of a new moon. For a solar eclipse to happen, there is a table here which also contains solar eclipses from 2012 to 2019. You can see here it says T or A. T stands for total, A stands for annular eclipse, and we'll explain that later. And it can tell you the mid eclipse, and then can you total time, and it gives you the regions where the eclipse is visible. Now it happens that on June 10th here, we're going to have a June 10th, 2021, we're going to have a solar eclipse. But unfortunately, we're not going to see that here in Al Ain. So people, I think in Europe, somewhere in North America, they will be able to witness that. But here in Al Ain, we're not going to be able to witness that, but I will tell you later that we had it last year. We had here last year on June 21st, 2020, which was the beginning of the summer. We had here in Al Ain a solar eclipse. It was not a total solar eclipse, but you can also get maps. There is a site called Date and Time, and you can go there, and they will give you a map of where you can see this eclipse, and they give you the colors here, if it's 100%, if it's 90%, 40%, how much of the sun is covered at your location. So this is calculated and predicted, and that happened last year. We were able to see a solar eclipse here in Al Ain. It happens that this year, June 10th, 2021, there is a solar eclipse, but it's not visible from our region, again here as a globe, and they give you these different colors to for last year where we had the eclipse, and the eclipse in Al Ain here was an annular eclipse. And we will explain what an annular eclipse is. So now, when the shadow of the Earth, the shadow of the moon, starts basically covering the sun, the disk of the sun or the photosphere, We always look at the photosphere from here. Now, what will happen, it's basically, and this is what sometimes made people think that there is a big monster in the sky eating the sun or consuming the sun. So it starts basically covering parts of the sun till it basically covers the whole photosphere of the sun, and that's photo means light, and that's what we see, and we call this the photosphere. It may become clear in chapter number 8 when we talk about the atmosphere of the sun. Now, when it is totally blocked, that means we have a total solar eclipse. In that situation, we're going to see the atmosphere of the sun. And the atmosphere of the sun, basically, it's made, of course, the photosphere of the sun, and this is the photosphere of the sun. That's what you see in this photo here. Now, on top of that, we have another layer which we call a chromosphere. On top of the chromosphere, we have what we call corona. And corona is like a crown. And that's why nowadays we give lectures online because of the coronavirus. And if you looked at how the virus is shaped, it has what it looks like a crown and on top of it. And even the sun, the top layer of the atmosphere of the sun, we call it what we call it corona. And there are special things that we can see that we call prominences. And these are only visible when we have a total solar eclipse. So scientists sometimes, they want to know where a solar eclipse will occur, so they have a chance to look at the atmosphere of the sun. So many basically prepare themselves and their equipments, and usually this total solar eclipses can last for 5, 6, 7, 8 minutes. It doesn't stay for a long time, unlike the lunar eclipse. And I think this is good, because if it did like the lunar eclipse, maybe people will get more scared. Now, there is an effect that we call the diamond ring effect. And that happens when the sun is not totally covered yet, so it's only portion of it, and it gives you that effect which we call the diamond ring effect. And these have been seen as well. So now, let's look at how we can look at different types of eclipses. But first, we want to look at the orbit of the moon around the Earth. And what we are having here, we basically exaggerating things. So it's nearly circular, but we know that the orbit of the moon around the Earth is elliptical. And when you have a circle, you have a center. But when you have an ellipse, you don't have a center. You have one focus there, and we call this T foci. So when you go around a circle, you're always at the same distance from the center. But when the orbit is elliptical, so in this situation here, the Earth can be only at one focus, cannot be at both. So sometimes the moon could be further, and sometimes the moon could be closer. So when the moon is at the closest position to the Earth, we call this perigee. And when it is at the furthest point from the Earth, we call this apogee. The same thing happens that the Earth orbits the sun as well. And when the Earth orbits the sun, And when the Earth orbits the Sun, also it does that in elliptical orbit. So sometimes the Sun can be only at one focus. So when the Earth is at the closest position to the Sun, we call this perihelion. And when it is furthest from the Sun, we call this aphelion. So that could make the apparent size of the Moon or the Sun smaller or larger. The size of the Moon or the size of the Sun is not going to change, but their apparent angular size to us. And it's not going to be that big. But now, when we look at the Moon, and when the Moon is closest to the Earth, that means at perigee, that's the angular size of the Moon. And when it's at apogee, which is furthest, that's the angular size of the Moon. So it looks smaller. And that's why I told you, when you look at the sky and we say super moon, super mean, but it's a wrong name, but it looks 14% bigger than usual because of its closest point to the Earth. And the same thing happens for the Sun. When the Sun is at perihelion, it looks the angular size, it's bigger than when it is at the aphelion. So now, what happens if we have a condition for a new moon and we have alignment of the Sun, Moon, and Earth? So if the angular size of the Moon is this size here, the bigger one, of course it's going to cover both of these sizes of the Sun, and you have a total solar eclipse. But what happens if you have this size of the Moon? It cannot cover this size here. So when they lined up perfectly well, it will give you a ring around. And this is where we call annular eclipse. Annular بالعربي معناها حلقي. So you will see this ring. And sometimes people refer to it as the ring of fire and so on. So when they lined up perfectly well, meaning Sun, Moon, and Earth, we have a condition for total solar eclipse. And they also can line up perfectly well, but we do not have a total solar eclipse. But what we have an annular solar eclipse, and that's what you see, what we call the ring of fire. And this is what we saw here in June 21st, 2020. When we looked at it, it was 90%. We did not see a total lunar eclipse here. Actually, this was taken on May 30th, 1984. So nearly, you're talking about 37 years ago from now. So when we look at a solar eclipse, we may have a total solar eclipse, and we may have partial solar eclipse when they do not really lined up, but there is part of it that can cover, the shadow can cover part of the Sun, or we have an annular eclipse. So we have these two types, either a total solar eclipse or partial solar eclipse or annular solar eclipse. Unlike the Moon, we have total lunar eclipse and we have partial lunar eclipse. Are these clear? But again, the conditions are for a lunar eclipse, you need a full moon. For a solar eclipse, you need a new moon. But when you have a lunar eclipse, many people can see this because it lasts for a longer time. But solar eclipse, it doesn't stay for longer time, and it only happens along a strip on the surface of the Earth. And that's why sometimes people go through their lifetimes without witnessing a solar eclipse, and they will witness a lunar eclipse. That's why we always say that people witness more lunar eclipses in their lifetime than solar eclipses, unless those who are enthusiasts and they actually go to wherever they have the means and so on, and they go to wherever these eclipses happen and they watch them. Now, observing a solar eclipse, and there is a myth always says if there is a solar eclipse, keep your children inside. And the reason for that is the sun sends many rays, and some of these rays are harmful to your eye. And I can give you, if you take a convex lens and you point it to the sun, it can focus the sunlight to a point, and you can burn holes through paper or through clothes and so on. So the same thing, your eye, the pupil in your eye is a lens, and that could damage the retina in the back of your eye where the image can form. So it's advisable not to look at the sun directly. Now, when there is a solar eclipse, especially children are very curious, so they tend to look straight. The sunlight can bend around and come to us as well. So you have to be careful with that. So the best way to look at a solar eclipse is either you use this technique where you make a pinhole in a cardboard and then you get the image of that, or you can use a filter. There are many filters now that you can buy, and you can look through them safely at the eclipse without harming your eyes. So the myth that you have to keep the children inside, I told you that children are very curious and they will actually look. So to use the scare tactic is the best tactic, where just keep the children inside. Now we have some arguments here. If you are on Earth watching a total eclipse, what would an astronaut on the moon see when they look at the Earth? I will leave that to you to think about, because you are witnessing here a total solar eclipse. An astronaut on the moon will see what? And what would astronaut on the moon see while people on Earth were seeing a total lunar eclipse? So I will leave these two for you to think about. I already did the when the diameter of the moon and the Earth are the same, but I will leave these for you to think about. Of course, these are, it could happen that astronauts on the moon get into these situations. Can we predict eclipses? Nowadays, we know how the moon orbits the Earth and how the sun is orbiting, and how the moon is and how the Earth is orbiting the sun. And we have sophisticated programs that can tell you exactly where the moon is located, where the Earth is located, and so on. But long time ago, there was a way, a rule of predicting these eclipses. And the simplest rule, it was for a lunar eclipse, you needed a full moon. For a solar eclipse, you needed a new moon. So, and these times were kind of less, you can predict them. So you know when a new moon can happen, when a full moon can happen. So you can predict at what times then you can watch the eclipse. So you cannot just go during any day of the month. It has to be either during a new moon for a solar eclipse or a full moon for a lunar eclipse. Now, we have a new moon every month and we have full moon every month, but we do not have a solar eclipse every month and we do not have a lunar eclipse every month. Typically, we have one or two every year. So what is basically causing this? It has to do with the orbit of the moon around the Earth. Remember in chapter number 2, we talked about the ecliptic. And we said the ecliptic is the apparent path of the sun around the Earth. So if you watch the ecliptic and you look at the orbit of the moon around the Earth here, you will find out that the orbit of the moon and the orbit of the ecliptic, they are not lined up. They are not in the same plane. They make an angle of about 5 degrees relative to one another. So you may actually have a full moon, or you actually have a new moon, and in the case of a new moon, you actually have the sun, the moon, and the Earth lined up. However, they are not one behind the other. And that's why you don't have a condition for an eclipse. However, when the two orbits basically intersect, and we call this a node. So when you have a node, this is when you have a node, and if it happens that you have a new moon or a full moon at this time, then you may actually have a condition for a eclipse. It could be either a solar eclipse if you have a new moon, or it could be a condition for a lunar eclipse when you have a full moon. Of course, if they're not lined up, you may have partial, okay, but when they are lined up exactly, these are the conditions for this. So long time ago, ancient Chinese, Babylonian, and so on, they had simple rules where they can predict that they are in eclipse season. They may expect an eclipse that could happen. So this is a cartoon here to show you how the Earth is orbiting the sun and how the moon is orbiting the Earth. They are not really lined up, and this is where the full moon and this is where the new moon, they of course happening at different times. So we can have a new moon or full moon, but they are not lined up. That means perfectly lined up one behind the other for a condition to have an eclipse. But as the Earth orbits the sun and the moon, you may have conditions where this could happen. And when that happens, you have a condition for an eclipse. Now, usually we look at the orbit of the moon around the Earth, and we make this plane here that you can see as the red color, and the blue basically the orbit of the Earth. When these two planes intersect, this is where we have the line of nodes, and of course this is the angle of 5 degrees between the two orbits. And when this is what we call ascending node. That means the moon is going up, and this is descending moon when it's descending node when the moon is basically on the other side. When you actually have an intersection here, and we call this the line of nodes. So if the new moon or the full moon happens along the line of nodes, then you have a condition for a solar eclipse or a lunar eclipse. And that was known a long time ago, that you can actually predict the eclipse season. And there is something called Saras cycle, which is 18 years, 11 days, and 8 hours. And 8 hours is 1/3 of a day. So sometimes you may hear 18 years, 11 and 1/3 of a day, meaning that the cycle is going to repeat itself of lunar eclipses and solar eclipses. So that was used to predict if we are in a eclipse season, and it was used by the Chinese and the Polonian and so on. They know it may not happen. Now we know exactly at what time and so on. Long time ago, they may actually have a new moon, or they're predicting, but they may predict, but it may not happen. But now we actually know exactly how the moon orbits, how it is orbiting, and so on, and we can calculate precisely at what time and locations and so on. So what you see here in the Saras cycle is basically this 18 years, 11 and 1/3 of a day, meaning that if you look here at the yellow and the blue, meaning the solar and lunar eclipses, and you can see that they will repeat again every 18 years, 11 and 1/3 of a day. So for example, if we look at something that happened in 1970, 18 years after that, that's 1988, but it will be at a different location because there is 1/3 of a day. And 1/3 of a day, the Earth rotates around its axis, that will throw it somewhere else. Now, if you wait another 18 years, that will be 2006. And it will be at a different location. These cycle of eclipses will repeat itself, but it may happen at different locations. But if you wait for another 18 years, and this case you add to this, it will be 2024. Now, you may actually have a chance for the eclipse to repeat itself in the same location. So if you take 18, 11 and 1/3 of a day, and you multiply that by 3, you're going to get 54 years and then 34 days. And that's where you may actually have a chance for the eclipse to repeat itself in the same location. So even long time ago, they can predict what times these eclipses can happen. So we actually, in this chapter, we talked about how the moon orbits the Earth and how the moon makes its phases, and we know at what times the phase basically rises and sets and so on. And we talked about 2 effects that are connected with the moon, which is the lunar eclipse and the solar eclipse. I will end up here with some misconceptions. Sometimes people are surprised to see the moon in the daytime sky, and they think something has gone wrong. I told you should not be surprised because of the rising and setting times of the moon. Many people think that the moon has a dark side. And I told you all sides of the moon basically see sunlight, but we always see the same side because the moon rotates at the same rate as it revolves around the Earth. Many people think that people tend to act up at a full moon, meaning they will turn into wolves and so on. And some reasoning for this: when there is a full moon, many, especially in the old times when there are no lighting and so on, many people will go out, and when it's a little bit dark, many people, or those who are they mean to do harm, they can do more harm. So statistically speaking, you may actually get more crimes at that time. And people thought, well, humans are not capable of that, so they must be turning into animals to do things like that. The moon is larger when it's at the horizon. And remember what I told you about the sun. When it's sunset, it looks a little bit bigger to you. The same thing happened with the moon. I told you you have to look at the super moon at its beginning in the east, and it looks bigger. And you can look at any full moon. When it starts up, when it's rising, it looks, it appears a little bigger, and then it will start getting smaller during the night. And that's basically an effect that has to do with the atmosphere and many things like that. So the moon itself is not changing in size, but that's the apparent size. Sunlight is somehow more dangerous during a solar eclipse. Actually, sunlight is more dangerous when there is no solar eclipse. But as I told you, when there is a solar eclipse, there is a tendency for people to look at the eclipse, and that's when basically they can damage their eyes. Any questions on these? Any questions? Everything here is clear? So in the next lecture, I think we'll do the review questions and we move on. Clear, good. You got all